I think this is good. We can get started. Yeah.
Are people still heading over? No, I still see the number creeping up.
Yeah. Well, they can catch up.
Cool.
Yeah. So this is a presentation that we gave at NI Connect as well, which is why it says NI Connect, even though we are aware that this is the GLA Summit. Yeah, this is the Introduction to Actor Framework presentation. Everything you wanted to know about Actor Framework, but we're too scared to ask. So let's just hop into it. A little bit about me. I'm Casey. I'm a co-founder of Zaya Solutions. I'm a LabVIEW champion, CLA, CLED. I have over 20 years of LabVIEW experience. A lot of that is with Actor Framework. I'm a member of the Actor Framework Guild and the Actor Framework Open Source Steering Committee as well. So yeah, and Dan.
Yeah, so I'm one of the other co-founders of Zaya Solutions and also a LabVIEW champion, CLA, CLED. It's basically the same answer. Also on the AF Steering Committee and part of the AF Guild. I guess I've been using LabVIEW since the late 90s. All right, so the point of our presentation here, we are supposed to go over what is the Actor Framework. And if we don't do that, we're probably not going to get invited back to present again. So that's going to be important. But before we get into that, Casey, what's a software framework in the first place? That's probably a good thing to lay out before we get into Actor Framework specifically. So I wasn't sure of the correct definition. So I went ahead and plugged that into Google and got the AI summary back. And then here you're seeing a slide. That's my summary of the AI summary. And it was probably wrong, but it sounds pretty good. So a software framework is a structure or blueprint to guide your code. It gives some sort of shape and structure to how you do things. It standardizes practices. It utilizes some reusable code to make sure that you're not doing everything from scratch yourself. It provides tools to make your work easier, and it allows you to develop harder, better, faster, and stronger, taking you from Mr. Bean to the sweet robots from Daft Punk. And we all know that those are clearly better programmers than Mr. Bean.
Right.
No doubt about it.
At this point, you're probably thinking to yourself, okay, you've sold me, Dan, you've sold me on using a framework.
Yep.
Frameworks sound great. I should probably just write one so I can use one from now on, right? I should write my own?
No, Casey, don't do that. You absolutely should not make up your own framework. Rather than doing that, you should definitely leverage the work of others and use something that is tested and scalable and maintained by somebody who's not you. Use something that has tools that go along with it, that has training material that you can leverage without having to make it yourself. And importantly, is understood by people outside your organization, right? If you start making your own framework and then you need to have somebody come and work on your application, you're going to have to come up with the materials to teach them how to do it. You're going to have to train them how to do it. No one's going to have any idea. If you use some sort of existing software framework, there's a chance, not necessarily everyone, but you'll be able to find other developers who already know how to work within it and can kind of come in and help you out, hit the ground running.
Derek, I can hear you hypothetically objecting right now to this, but you may be the exception rather than the rule. So.
Okay. So what it comes down to the Actor Framework is fundamentally, it is a way to launch loops and send messages between loops in your application. And there's kind of a bunch of different terminology you can use there for your loops. You might call it a process, you might call it a module, you might call it an actor. And then we know in LabVIEW when you're messaging, you can message in a whole bunch of different ways. So you could be using queues or events or notifiers. But pretty much when you break down most or all LabVIEW applications, it's basically a bunch of loops that are communicating with each other. Since Actor Framework is a framework, it gives you, provides the structure and the standardization and the tools to make your application, consistent and understandable and allow you to develop efficiently. And it doesn't leak memory. It makes sure your communication references stay alive when they should. It has tools and training and all that good stuff. Actor Framework has been shifting with LabVIEW since 2012. So people have been using this for well over a decade. It's powerful. It's scalable. is object oriented, but we're going to kind of propose here that you don't necessarily need to care about that, especially if you're just trying to launch some, do basic usage of Actor Framework, launch some independently running loops, and be able to message between them. You don't have to get deep into the object-oriented aspects of it, but they are there in case you need to do, more advanced things down the road. And there's an active developer community for the Actor Framework, including the Actor Framework Guild that we mentioned before, where we're trying to, come up with materials and improvements and things like that. It's open source, so you can look at the code and you can help us make improvements to it. All that good stuff.
All right. So as Dan kind of alluded to, our kind of hypothesis or thesis here is that if you understand a queued message handler, you can get started using Actor Framework. It's not that difficult. So let's look at some of the key parts of the NI queued message handler. So this is an example of a very basic application written using the NI queued message handler. And I'm gonna identify just a couple of key parts to it. First, you have the loop, the message handling loop at the bottom there. And that's really where all the guts of the program takes place. In each of those case structures there, you have code that executes that kind of makes up the module or the queued message handler. There's obviously got to be a way to launch the code to start it running. For a queued message handler, you just hit the little run button in the LabVIEW IDE. And lastly, for the purposes of this presentation, we have the message itself, or the way that you enqueue a message for that message handling loop to receive. And that you can basically, in programming terms, you can think of it as the API to this queued message handler. Okay, so that's great. I have a simple queued message handler. It does the stuff that it communicates via the messages. It executes code in the message handling loop. That's great. But pretty soon after you write a simple one, things start to grow, right? What if I want to add data acquisition to my application? What do I do? Do I add another loop and another queue? Once I have data acquisition, I probably want to process some of the data that comes back from that data acquisition loop. What do I do then? It's another loop, right? Another queue potentially. Oh, I've done some processing on the data. Probably want to log that so I have it to look at later down the road. I have it saved. I can go back, check it out again. What if I want to add more data acquisition? What if I want to add another copy of the same instrument? How do I do that? And how do I keep track? How do I communicate with all these loops? Do I just store all the enqueuers, all the queue references in this cluster here, or what's a good way to do that? And soon you can end up with just like a lot of spaghetti code, right? So what's the problem here? This slide sort of summarizes some of the problems with the NI queued message handler as we see them. It's taken from Darren Nanninger's presentation, or heavily inspired by that on the introduction to DQMH. So some of the things that you might be thinking, or hopefully that communicated, was that communication between loops is not straightforward. You have to manage a lot of different queues, and it's not scalable for systems where there are lots of different modules and communicating between them, because you'd have to maintain or you have to figure out how to maintain and deal with all those different enqueuers or queues. It can be difficult to debug, right? You can't control who has access to the QMH's queue, so messages can come from anywhere. And also, because that input for which message you want to execute isn't strictly typed, it's just a string, it can be difficult to search for and find when you're trying to debug. The messages are also not type safe. In the classic queued message handler example, you would queue a string for the message that you want to execute, or the code that you want to execute, and then inputs that come along with that are a variant. So you only know if you haven't put the right kind of data when you enqueue that message, when you try to transform that data back into something else. There's limited reusability. Modules are often tightly coupled to other modules. Like if one module calls another module, then anytime you want to reuse the calling module, you'd have to reuse anything, or you'd have to include anything that it called. So There's also no built-in mechanism to support multiple instances. Like I was saying, if you want to have data acquisition and you want to have two instances of the same instrument that you want to communicate with, there's not a good way to do that with the standard NIQMH. And adding new functionality requires a lot of manual changes. There's not much that's scripted in the NIQMH, if anything at all, besides the initial creation. So you have to add frames to the event handling loop and the message handling loop manually, and that can be tedious and error prone. So what can we do about that?
Well, actors to the rescue. They're a lot like the queued message handler you might be used to, but more flexible, more scalable, and definitely pet friendly. So, kind of going through the pieces here that we just talked about, and Casey gave us, I'm going to show you how they map in the traditional queued message handler to the equivalent thing in Actor Framework. So, the kind of queued loop here, and this is where some people get hung up when they first switch to Actor Framework, because they're used to opening the one big VI that has the case structure and the loop you're working on. And that's not the setup in Actor Framework. In Actor Framework, there you go. Instead of having the one big VI with the loop and the case structure inside of it, you've got a library on disk. And the library contains a bunch of separate files. There's an actor class, which contains a bunch of methods or VIs. And then there's message classes for the things, for how you communicate with it. And if you've ever, been working on an application with more than one developer, you might have run into issues where you both need to work on some part of the code, but there's one big giant VI, so you need to take turns and hand off and things like that. Breaking the code up into a lot more granular pieces, like you have in an actor, makes it a lot easier for multiple developers to work on things at the same time without stepping on each other's toes. And really, even if you're the only developer working on it, rather than it makes it a lot easier for you to track your changes. So when you go and look in source code control, and you want to figure out what changes you made to a part of your application, you can have a lot better idea of what you did and what might have gone wrong if there's an issue, if things are broken up into smaller kind of bite-sized VIs that are the chunks of what it does. You can say, oh, I just changed the acquire VI in this case, and not my entire loop where who knows what could have happened. So that's the loop. The next part is the messaging. So as Casey was saying, and as we sort of saw in the example there, oftentimes the way that people message to a queue-based loop is you enqueue some combination of a string saying what the message type is, and then a variant that goes along with it. And that is replaced in the actor framework with a bunch of send methods. So for every message you can send it, instead of a string you're going to put in there, it has a single method to send the message. And that message has completely type-safe inputs, right? So there's no way you can accidentally send a double along with your message when you're trying to, when you need to have a string that goes in there instead. And you'll see that it kind of shows up in your library there as a message class with a couple of VIs and the private data of the class in it. But you can basically ignore all that. I never look in those. You never open those. The only thing that really matters is for each message, for each thing your actor can do, there's a send method that goes along with it. And when you want to communicate tell it what to do from another part of your application, you just use that send method. Cool. The next part is kind of the loop itself. So in the message handling loop, you have a loop, and then inside of it, you have a case structure. Oh, I guess, no, maybe not that. So the loop itself, getting ahead of myself, the loop, you never have to rewrite again. You don't have to, you're not going to maybe plop that down and make it take up 4 screens. The loop actually gets inherited from the actor framework base code. So what you end up with is this inherited VI. You never have to open it. You never have to look at it. The loop just runs by itself. And what's more important is what happens inside the loop. So the things the actor can do, right? If you're looking at an old school message handling loop, what you have are a bunch of different cases inside the case structure, and those are all the different things that your loop can do. In the actor framework, every single one of those cases becomes a VI on disk. So you can see there that has the exact same content for the display text case inside the case structure and the display text VI. So basically the same code gets written. You've got the wire going into it there, which is the cluster in your old school message handling loop. Up here, it's just the actor class going in, but you can do the exact same bundling and unbundling of data that you need to use, and you just can write up the things that you do one VI at a time.
Yeah, this goes to the point of you don't need to know a ton of object-oriented programming if you want to use Actor Framework. You can treat the actor wire as just a cluster that you bundle and unbundle.
Yep. And oftentimes we refer to those the individual VIs that get run when your actor receives a message. We often call those payload methods. It's kind of like the payload that executes when the message is received. And then the last part, launching the actor. There's a VI you get to use from Actor Framework that you get for free. That's launch actor, and it takes in the actor you're trying to do. In this case, the example is the DAC actor. The actor wire goes into that VI, and when you call that VI, it launches the actor in parallel. You don't have access to the actor anymore. The actor is off running in a parallel loop, somewhere in memory on your computer, and all that you're left with after calling the run VI, which executes immediately, is the thing that comes out the other side there. And what that is in the actor framework is called the enqueuer. So there's a launch VI, but which is kind of a fancy, kind of confusing word actually, because it's not quite the queue. But really, what it is the best way to think about it in my mind is that it is the address for your actor. So your actor has started running in parallel, off in memory in some loop. The way you communicate with it is by sending messages to its address. And if that looks familiar to you, it is the input to all of the send VIs that we just talked about. So for every message you want to send it, there's a send VI. What it takes is the address that goes along with it, and then any required arguments that you can't help but include.
All right.
And all that said, yeah, it's Casey's chance. No pressure to do a live demo of making an actor and showing how easy it is to create some methods and messages and make it all run.
All right, so let me share the development machine. Any questions in the meantime while I'm getting this set up? Just feel free to put them in the chat. All right. I'm going to keep going. All right, so we have two projects here that do the exact same thing. One is written using the standard NIQMH. One is written using Actor Framework. And I'm going to show you kind of what Dan talked through, how the different parts of it and how they're similar and some differences as well. I'll leave that open. All right, so let me just show you what this application does first. So like I said, let's run it, hit the run button there. This is just a text display here where it takes in the text that's down here. And when I click this button, it's going to take whatever text is down here and put it up there. So there we go. Hello world. I can say GLA Summit 2025. Hit display text. It's just putting the text right up there. So really simple application. Let me show you how it works. A lot of these, the code that you saw in the presentation were screenshots of this, so it should look kind of familiar. Like I said, we have the message handling loop here. We have the event handling loop. When the display text button is pressed, it enqueues the display text message. The message handling loop, that message is received, or that event, that particular element is dequeued, and it's fed into this case structure here where you see a list of the things that this particular QMH can do, display text being the one that was enqueued here. And in this particular case, it's updating the display, the text display, using a property node where it just appends the new message to anything that already existed. And as you can see here, it's taking, you can see from the red coercion dot, as we mentioned, it's transforming this or converting this into a variant. When it comes through here as a variant, you're converting it back to a string so it can be appended or concatenated on the existing thing. So easy peasy, right? Let's take a look at the exact same thing in Actor Framework. So as Dan was mentioning, you don't run the actor directly. You just use the VI, this launch root actor here, that launches the actor. But once it's going, we have the same or very similar window. Same behavior. If I click this button, it's going to put text up there. welcome. I do this. So no funny business here. It's doing the same thing. When I click the button, it's just taking whatever text is there, putting it in this window up here. So let's see how this looks different, right? So you have main in a QMH. You have actor core for your GUI in Actor Framework. And if we look here, there are some parts that are similar, some parts that are very different. The message handling loop is in this call parent method node. Like Dan said, you don't have to write it again. It just runs automatically. What you do have, though, which is very similar, is this event handling loop, where, again, when the display text button is pressed, it enqueues the message. Again, this is the address for the actor. In this case, this is the self enqueuer, which means this is this actor's own enqueuer. This is something that comes for free also. I'm showing the palette up here, which is found. I guess I can show where this is. Let's do it this way. Whoa, what is my computer doing? I'm not clicking on a VI. Yeah, data communication actor framework. So for this actor, it wants to enqueue a message to itself using its own address, and the text that it's taking is this control here. And to see what it actually does, the equivalent of the case structure in the queued message handler here is that display text VI. And if we compare this to here, essentially the same code. It's taking the text in, it's appending it to the existing message buffer, and it's updating the control on the front panel via a property node. One thing you don't have to do here, which we've touched upon a couple times now, that you don't have to convert it back from a variant into a string. Everything is strictly typed. So when the string goes in here, it's still a string. It doesn't get converted to a variant. When it's used here, it's still a string. So if you were to wire in the wrong type of data, it would break the wire immediately, and you get that feedback before you had a chance to run the program or potentially do something that you didn't want it to do.
Yeah, detecting issues at edit time is always much better than detecting issues at runtime.
Right. So yeah, the biggest differences are that the code is broken up versus a traditional queued message handler into different VIs, whereas this would all be on the block diagram of the same VI. The main in a queued message handler, this is in a couple different VIs here, actor core, and then the payload method for the particular message that display text. Payload method is where the code that you want, the business logic actually executes. So hopefully that makes sense and shows you how things are the same. Dan likes to drop out for some reason, but that's okay. We don't need him right now. All right, so I'm going to close the QMH project for the moment. And what I'm going to do now is show you how you can add functionality to an existing actor. So this is great. This already exists. But what if I want to create a new actor, right? How do I do that? For this example, what I'm going to do is I'm going to create a new actor, and I'm going to simulate some data acquisition. So I'm going to call this a DAC actor. So how do we create a new actor? All you need to do is in your project, right-click, say new on your target, say new actor here. And like I said, I'm going to call it a DAC actor. And it's going to, when I say OK here, it's going to create a library which contains all the actor class itself and a virtual folder for the messages or the API that you use to communicate with that actor. Save everything. And that's it. That's all you need to do to create a new actor. You've done that. Now, if I want to communicate with this actor, the way that I do that is first I need to launch it, right? Because this actor is created, but it's not actually running. And the way that I run the new actor is I can drop the actor that I want to run here, and I can see that it has a banner for a description. So I can go ahead and update that just like any library or class if you're familiar with that. Add this icon. I'm gonna say DAC. Oops, not there. And now all the methods of this class and the class constant itself has this nice DAC identifier there. And what I want to do is close this a little bit too soon. Using the actor framework palette, I want to use the launch nested actor VI. So what this does is from an actor launches another actor. So I'm going to do this. Just fire it up quickly. Let's just put this up here for now. So I do this and I've launched the DAC actor. And what's the last thing we need from that? If we want to communicate with it, we need its address or enqueuer, right? So I'm just going to wire this to this event structure so that we have it for later. So now I have the main actor, the data display actor, and it's launching this DAC actor here. Now that's great, and we can communicate with it, but this needs to be able to do something now. So we need to add another method, add behavior to this actor. So I said this is a DAC actor. It's going to simulate data acquisition. So I'm going to create a method in here. Let's call it. I'm going to call it acquire data. Okay, give it an icon. What this guy is going to do is I'm just going to take the current time, use the timestamp, and I think this has to be converted to a double. I'm going to just take the sign of this. Again, we're just simulating data. It doesn't actually have to be anything sensical. I just want to get a numeric value, like it's acquiring data from some hardware. And yeah, it is broken, so I have to convert this to a double first. And then what I'm going to do when I have this this value is I want to send it back. I'm going to use the existing message that I was using already in the data display actor, the display text message. So I want to send this data back so that data that I acquire shows up in this in this text display right here. So this is the, if you recall, I launched this nested actor, right? So how is this going to send message back to the calling actor, the actor that launched it? Again, there's an API on the palette that's included with LabVIEW for free. I didn't have to write any of this. Read caller enqueuer. So if I put this in here, now I get the address, the enqueuer, the address of the calling actor. So I can use that to send a message back to this particular actor.
And the calling actor is just whoever was the one who launched it in the first place, right?
Right.
Whatever actor the launch nested actor VI was plopped down in the block diagram of, that's who the caller is.
Right. So again, in the messages that are for this actor, I don't need to pay attention to any of this stuff. The one I really care about is the send. So I'm going to send display text back to the calling actor. I'm going to use the address of my caller, and I'm going to send it back this data. It's broken. Why? Yeah, really trying to hammer this home here. This is not the correct data type, right? I've tried to send it a double. It's expecting a string. And it's telling me immediately, it's giving me a broken arrow. I can look here and see connected two terminals of different types. So what I can do here, though, is, so I'm just going to convert this from a double into a string. Let's just do that. And now, when this code executes, it should send the current date time, the sine wave, the sign of that back to the calling actor to be displayed. So now I actually have to, so that's creating the payload method, right? So that essentially the equivalent of the code that's in the case structure on a classic queued message handler. But I need to create the message for this as well so that other actors can tell it to do that. How do I do that? What I have to do is right click on this method, the payload method in this actor. There's an actor framework menu that pops up. And if I say create message, this is all scripted for you automatically. it created the class, and it created all the supporting VIs and files for it. Again, the one that we care about is the send acquire data. So now I have a new actor, the stack actor. It does something, and I also now have a way to communicate with it, to tell it to do that thing, that action that I just created. So using this send acquire. So last thing to do here is I want to put this back into my display actor, the calling actor. I'm going to create let's create a new method here, or a new use this button. Say acquire data. Let me just rename this so it's proper. And now, when this button is pressed, I'm going to create an event for this. So add event case. On.change. Now, when I click this button, it's going to communicate with the actor. Again, which actor? It's the DAC actor using its address, and it's going to tell it to acquire data. It will execute this case and send that information back to the display actor. So if I did this correctly, moment of truth, let me run this. Again, get to launch it from here. And this should still work. Hello world. Hi. But now if I click acquire data, that code is executing. I do it again. I can do it a few more times. It's just taking the sign of the date timestamp and sending it back. So that's as simple as it is. We started with one actor that had supported this display text message. We created another actor, an actor from scratch that sends data back to the calling actor to be displayed. We created a message for that actor so that other actors can interact with it, and we integrated it into the existing application. So
yeah, you'll also notice that built into the framework there, when you stop running, it shuts down your nested actor automatically. So you don't have to worry about accidentally leaving the loop running in the background or something like that, and having LabVIEW be sitting there with a busy run arrow forever. It automatically shuts down by default.
Right. If anybody has done stuff with queued message handler where you add multiple loops running in parallel, there's always that question: how do you shut them all down, right? And maybe you end up with like a local variable that's in use that, like, when one shuts off, the other gets shut off, something like that. Yeah, Actor Framework takes care of that for you. So we have some time still. So what else can we do? So we've created an actor, and it returned this the display of the numeric data that it sent back. But one thing I don't like about this necessarily is that the data it sends back, it has no time associated with it. I mean, it dealt with the time. It took the sign of the timestamp. But I don't know if this data here was acquired 5 seconds ago, 5 minutes ago. I have no way of knowing, right? So I want to modify this actor, the behavior, so that in addition to returning this information, it also returns a timestamp with it. Okay. So I could go in, I could open this VI, and I could modify this and add the timestamp here. But actors are very self-contained in a lot of cases. So what if I'm using this actor in another application where it's not expecting a timestamp? I don't want it to have to deal with a timestamp that comes back. It might be using this in a way that's important to it. So I want to reuse a lot of the functionality, but I don't want to change it in any actor where that might be using it, where it's used in another application. So how can I do that? And this is getting into a little bit of a more advanced topic where we are going to do some object-oriented aspects of using actor framework. You don't have to do this if you're getting started, but we do want to kind of just show the power that using a framework that leverages object-oriented programming, what it can deliver. So I have a DAC actor here. I want to create a DAC actor, but I want to have a timestamp. So I'm going to give it the creative name. I'm going to create a new actor. I'm going to say new actor. Oops, not interface. I'm going to call it DAC actor with timestamp. And I'm going to change the inheritance here so that it inherits from the DAC actor. So when I do the actor,
what that really means by inheriting from the DAC actor is it uses all of the functionality of the DAC actor without having to rewrite any of the code. Big, simplified explanation of the inheritance. You get everything the other one does, and now Casey's going to change just one part of the functionality without changing anything else.
Right. So I can demonstrate this, what Dan is saying actually by, I'm going to modify this icon so that I can tell them apart. So let's see. Put a cute little clock there. So now this, I can tell this apart if I put this on the block diagram. Right. So I have another DAC with timestamp actor. I'm going to launch this one as well. And do this. And let's with timestamp. Let me create another case here. So I'm going to, as Dan was saying, this actor inherits the behavior, all the functionality of its parent. So this DAC actor here, without having to write any new code. So even though this actor doesn't have a message class itself, it can use its parent's message class, in particular the send acquire data thing. So I'm using the same VI for the DAC actor. I'm going to use the same one for the DAC actor with timestamp. I'm going to use the DAC actor with timestamp's address instead of the other one. And now, if I run this, display text, this works. If I click this one, it returns data. If I click this one, it returns data. It doesn't have a timestamp on it yet because I haven't modified that functionality, but you can see that there's no extra code in this actor, but it's doing the same behavior as its parent. So what we really wanted to show is that you can change the behavior, just the parts that you want, right? So what I'm going to do in this case is I'm going to create a new override. This is an object-oriented technique also for the acquire data VI, which just means, hey, I want to have the same behavior as its parent, except for this particular VI. I'm going to change what this particular VI does in relation compared to its parent. So,
and obviously in this case, it's a little bit of a silly example because the actor only does one thing to start off with. But you can imagine a use case where your DAC actor, has 10 different functions that it supports, and now we're just changing one of those functions. All the other ones still work the same way, but just this one functions differently with no duplicate code.
Right. So I'm for the sake of simplicity of this example, I'm just going to copy the code over for now. But what I want to do is I want to add that timestamp that I was talking about. So I'm going to use the get date time string. This one, I believe, where oops. All right, so I want to show seconds. It's going to take in the same timestamp here. And I'm going to include the time string now along with that data. So here, what I'm going to do is, and I'm going to use just these 2 colons as a delimiter, just to make it easier to see. And now, oops, and actually, this is wrong. This is a string, right? Okay, so now I'm just adding in this beginning part of the string here where it's appending the timestamp in front of the data. There's a question in the chat, Dan.
Oh. No, it's inheriting the send, the entire message class and the send VI and everything else are being inherited with the first actor. We're just overriding that one VI that does the thing. So the second actor will do the thing differently.
Okay, yeah. So again, I'm using the same VI. I'm sending the same message, but how it executes that message is different between the two. And since only the execution of that message is different, that's the only part I need to override or change between the two actors. So now if I run this code, again, I acquire data. This is the original one that is using the address of the original DAC actor. But if I use this one now, it's getting the information back along with this timestamp that it appended to the front. So yeah, I did not have to recreate this message to do it. All I did was change the code behind the acquired data because that's the only part that I wanted to change.
Yeah, and those two actors are completely independent, loops running off in memory somewhere. They're in no way interacting with each other at runtime. If one of them takes 10 seconds to return a response, that's not going to impact, how fast the other one gets back to you.
Yeah. Let's see, where are we? We're actually ahead of time, which is unusual for
speedy today.
We've done this presentation before. Okay, so I think that's the conclusion of the demo, or what we wanted to show with the time that we had for now. Are there any other questions before we go back to the slides? All right. So yeah, again, just to summarize, we started with an existing actor. We added a new actor that we wanted to talk to and have it send information back. So two-way communication, right? We want to send a message to the new actor, have the new actor send a message back to the caller. And then as a bonus, we created an actor that inherited from this new actor that we created so that we could modify just only certain parts of the behavior. And we did that using the scripting that's built into LabVIEW. Nothing besides the actor code itself was, it was using, let me phrase it a different way. All of the scripting and creation use code that ships with LabVIEW. You don't even have to go into VIPM and download a third-party package. It's just included with the base installation of LabVIEW through the menus and also through the palettes, the actor framework palettes here. So,
I see another question there in the chat. Yeah, interfaces. That's a little bit more of an advanced topic. But you'll notice that we made 2 or I guess 3 actors today. These actors are kind of coupled to each other. So right now the DAC actor is relying on a message from the data display actor, and the data display actor is relying on a message from the DAC actor. So they are kind of coupled together. If you pulled one of these drag one into a project, you're going to have drag in the other one in dependencies. A good way to be able to decouple that and make your actors really not coupled to the code of the other actors that you're running is to use interfaces. And you kind of set it up so that an interface contains the messages you care about, or maybe the messages that an actor sends back to its caller. And the interface allows you to kind of decouple them so that everybody's only kind of coupled to the messages that go back and forth and not coupled to the actual implementation of what happens when those messages get done. So kind of an advanced topic, but super, super useful. It really allows you to make very nicely decoupled, testable, scalable code.
Yeah, it's pretty handy. I think in general, once you start, if you're diving into actors and have done it for a little bit, I think you want to switch to using interfaces sooner rather than later, because it really helps with keeping the code nice and performant and decoupled and reusable.
Mm-hmm. Yeah, it makes it far easier to write actors, or loops that you can really reuse across applications and stuff like that, because you can make them very nicely decoupled from the other parts of your application. So you can have a logging actor that just you can run in any application you choose.
Right. All right, so that's kind of the demo kind of is concluding the meat of the presentation, but there are a couple things we didn't touch on. Um, Also very complex. The interfaces. Is that what you're alluding to? Yeah. Um, I I don't know if I necessarily agree with all of that. It is another thing to learn, but it actually simplifies the code, I think. So yeah, we can
Yeah,
talk more about that too.
yeah. You'll have to get the hang of it, but it's very, very useful once you do.
All right, Dan, you want to tackle the concluding thoughts?
Sure. Yeah, that's our demo. We're happy to answer questions. There's a lot of stuff we didn't really talk about much today. Yeah, I mean, there's all sorts of other topics you could really get into, like just general LabVIEW object-oriented programming. There's other actor fundamental methods, like what happens when an actor shuts it down and it messages back to its caller. Didn't touch those. There's also like startup and shutdown VIs that you can force to run. Didn't talk about those. There's kind of how messages default through your actor tree to start off with, dependency management, the interfaces that someone has already asked about, best practices for how to make actors, clean. Additional tools, like there's a bunch of community tools out there. One that we put together is called Bowser. So Bowser is actually allows you to look at the messages your actor supports, both inherited messages and your own messages, and then look at them all kind of in a side window, kind of like you're scrolling through the different cases in a case structure that might be in a traditional message handling loop. So I think a lot of people find that handy to be able to kind of have a little bit less of a mental load switching from a traditional message handling loop to an actor. Open source actor framework is an initiative Casey and I are both involved with. So there's all sorts of other things you can learn about and talk about, but we were just going over the fundamentals today of how to make an actor and run it. And hopefully that allows you, if you haven't done it before, to play around with making an actor and seeing how it might work on your end.
There's a question here: if there are a number of actors in a project, how to figure out which one is the root actor? Kind of just like you would with any QMH or like DQMH actor framework. It's basically the first one that you launch. It's your main one that all the other actors are launched from.
Yeah, and if you were just handed a project that says, "Hey, here's a bunch of actors. Which one's the root actor?" You just look inside the launcher VI. The launcher VI will show you which one's getting launched as launch root actor.
Yeah, and if you can't find the launcher VI, hopefully they have a build spec where you can go see what the startup VI is, and you can use that to identify the launcher VI.
And then you'd request that person looks back at best practices to not make it so confusing.
Can you have multiple launch root actors? You can. Like if you had an application that wasn't entirely actor framework based and you wanted to, like as a subsection of that application or partition part of that application, launch actors, you can launch actors from anything basically. It doesn't have to be another actor it's launched from. Yeah, the challenge there, if you do that, if you launch multiple root actors, is how do they communicate with one another, and how do you get messages back to the code or the module, whatever it is that has launched those root actors. It's easier to have a single root actor so that it acts as like the top of the message tree. We didn't really, that third bullet point there that we didn't really touch upon right now, message routing tree hierarchy.
Yeah, I mean, Derek's saying there that actors aren't meant to talk to non-actors. And yeah, I mean, the default messaging for an actor to kind of talk to the rest of the system is to get its caller and queuer and just send a message of some sort to its caller, which then hopefully the calling code knows who the right recipient of that is or figures it out if it's not the person who receives it. But it's very easy to if you're running from code, you want to launch an actor, and I've done this in some application that was built using some other sort of message handling functionality. There's a queue you want to send a message on. Once you've done something, you can pass that queue into your actor before you launch it and then use the queue to send it up. I'd recommend, wrapping up that functionality within some sub-VIs or something so that if later you want to use the same actor in a, actor-based application, you're not tied to that queue still. But yeah, I mean, you can definitely message, use any of the tools that exist in LabVIEW from within your actor.
Like Derek is suggesting his own promises library.
I'd love to learn more about that.
Some additional actor framework resources beyond this. For training, there's NI's own actor-oriented design and LabVIEW course. I think Alan Smith gives that when there's enough demand for it. Um, so talk to your company if they want to send you on that training. It's very useful, I think. Tom's LabVIEW Adventure is a great YouTube series that in part touches upon Actor Framework along with some other frameworks as well, but he has a great kind of mini series there on how to use Actor Framework. I think it was developed before interfaces existed, but he did make an addendum so that you can kind of see how interfaces can be used with Actor Framework. Going back to Jesper's question about that, there are a couple different Discord servers. There's the Actor Framework Guild and the NI Open Source Actor Framework. For everything NI Open Source, the Actor Framework Open Source Initiative is part of that. The best way to find those Discord servers are go to the LabVIEW wiki, so labviewwiki.org, and search for Discord, and you can see a bunch of community managed Discord servers. Beyond Actor Framework, there's a bunch of other ones as well, but that's where you can find those two that I mentioned there. And finally, the presentation links, the slides and the code that we used. So these slides that you're looking at and the code, both in its before and after state, I guess, can be found at that link there on GitLab. I can copy this link into the chat if it's helpful.
Yeah, responding to what Fab is saying there. I think a great future AF Guild task is going to be to kind of recreate or port over the API tester stuff from DQMH to work with Actor Framework, because it definitely is nice using DQMH to be like, oh, just make the tester automatically. In Actor Framework, you have to make up the tester by yourself, which is more convenient if you can leverage some scripting to do it.
Yeah, that is something that was not the NI open source Actor Framework stuff, but there's a project that was started by Sam Taggart that kind of I messed with it a little bit, but I haven't had the time to extend it much further. But if people are interested, we'd love to see people work on that and kind of incorporate that sort of functionality.
Yeah, definitely.
To Actor Framework.
I think it needs some expanded functionality to kind of be general purpose, with especially with interfaces and stuff like that, I think, and inheritance, compared to the Sam Taggart one.
What is that thing in there? Somebody tell me if that link works.
That's a broken picture.
Yeah, I don't know why it shows a broken picture, but
it takes me to GitLab. Okay. So I believe it works.
Cool.
Okay, so the question from the start. When do you need to make something an actor? I like doing. I mean, when you're making any sort of application, I guess, or when I'm making any sort of application, you need to settle on, I think, off the bat, some way to be like, hey, how am I going to launch loops, and how am I going to send messages between loops, and how am I going to create nice wrappers around those messages to make sure they're type safe and stuff like that. And pretty much anytime I'm making a loop or starting up making a new application, I will just start making actors. It's very straightforward. The tools are there to script up making your messages and stuff like that. It's way easier than plopping down sort of the queue primitives on a block diagram and starting from there. So I guess my answer is always make it an actor, unless your application already does something else.
if you need another concurrently running loop, right?
Yeah,
that's oftentimes you just make it an actor. It's easy to do. The scripting that's built in.
Yeah, I mean, I think any framework, like it's your application, assuming you get to start from a blank page, using some sort of framework to make the loops consistent, all your loops consistent, I think is a big advantage of, any sort of framework.
Real quickly touching upon the debugging and stuff. So because the actor core is inherently reentrant, that can be a little bit more difficult to debug, but with tools like the actor hierarchy inspector that Alan created, it serves much the same purpose as MGI's monitored actor. You can get into the particular block diagram of a particular actor fairly easily, and then also the payload methods for different methods in actors. If you can probe and debug those the same way you would with any other code in LabVIEW. By default, those methods are going to be non-reentrant, so you can just put down probes and check that out. I saw that part of the presentation that you guys are referring to. All right. Well, if anybody has more questions about Active Framework or how to get started, we're happy to talk more about it. Yeah, we find it to be we're familiar with a lot of different frameworks. We've used DQMH Active Framework. Our preference at Zaya Solutions is to use Active Framework, but I think one of the takeaways we're trying to show is just use a framework. Don't try to just create your own thing from scratch too. And if your inclination is to try or want to start using Active Framework, hopefully we've given you some resources to help getting you started with that, and we're always here to help with some of that if you want to reach out as well. All right. Well, there's no other questions. Thanks everyone for showing up. I think, did we put a way to find us? LinkedIn, probably the easiest way for if you don't.
I updated my profile, so yeah, you can get to my LinkedIn or our company website if anybody wants to reach out and get in touch.
If you like search for our names that are right here on LinkedIn, you should be able to find us fairly easily, I think. All right.
Cool.
Thanks everyone.
Thank you very much for coming.